In this video, we are going to talk about linear relations and functions. So we want to be able to identify what they are, look at a variety of different forms, and there you go. Okay, so a linear equation versus a non-linear equation. A linear equation will be in the form either ax plus by equals c, where a, b, and c are real numbers, or y equals mx plus b, or f of x equals mx plus b. So those are the three most common types of linear equations. You'll notice that our x and y have no powers on them. We have at least an x or a y, but if you have both, then you see more of a linear function. And so it's important to be able to recognize what is linear and what is not. Now, what is not linear is if your x and y are touching, if your x or y are in a denominator, if you have a power on your x. So if we look at our first example, this is nonlinear. And the reason it's nonlinear is because of the squared on the x. Another example of a nonlinear is if you had 1 over x. Yeah, the x is still to the first power, but it can't be in a denominator because technically that indicates a negative exponent, which we can't have. You can't have any exponents other than positive 1 on the x and on the y. And they can't actually be multiplying together either. This is a linear function. It's what's considered standard form, which we'll talk about more a little bit later. And then this is linear. Now, it might not look linear, but if you write it as y equals 0x plus 7, that looks a little more like a linear function. So linear functions or linear equations will have an x and a y separated to the first power, or just an x, or just a y. Okay. Now, a linear function, you have to be able to solve it for y. This is your y. It has to have a y in the equation. It can even be y equals a number. It's a horizontal line, but it's still a function. So x equals a number. It's a line, not a function. Can't solve for y if the y is not there. Y equals a number or y equals mx plus b are the types of lines that are functions. So just a little distinction, what is a linear function? A linear equation could be x equals 7, y equals 7, 2x plus 3y equals 4, x equals y plus 7. Those are all linear functions. Or, I'm sorry, linear equations. The functions have to have the y there. They have to be able to solve for y, and you can replace the function notation with the y. So are these functions linear or not? Well, this is not linear. We talked earlier about the fact that you can't have a power on your x. This is a line. This is a linear function. You can see that f of x equals mx plus b. This, although the x is to the first power, is nonlinear because of the fact your x is in your denominator. And so that looks very different. If you put any of these into Desmos, you could type exactly what you see there. This one here kind of has a little curve to it, not a line. This one here is a line. It's a perfect line with a slope of 4. This one here is in 2 pieces, approximately. I'm sorry. It approximately looks something like that. So, okay. So here's a real-life application of a linear function. It says we've got this growth rate. The grass is growing at a rate of 5.9 inches per day. So our f of x is inches. So we can even say that's our y. And the x is in days, okay? So to find the height after 3 days, since the f of x is related to the height, it's the length inches. So you're just going to plug in 3. So 5.9x, or I'm sorry, the x is now 3 plus 3.25. Now, following the order of operations, you have to do the 5.9 times the 3 first. You have that multiplication first. And that's 17.7 plus the 3.25. And it would be, because it is an application problem, please tell me the units, it would be 20.95 inches. So if you look back at the original function, the question is asking, well, what does that 5.9 on the x stand for, and what is the 3.25 on the equation? Well, the 5.9 is the slope. Slope is a rate of change. And in this particular case, our slope, or our grass, is growing, because it's positive, it's growing 5.9 inches per day. See how it's a rate? We say that per day, okay? Now, the 3.25 would stand for the initial height. Now, why do I know that? Well, it is actually our y-intercept, if you looked at the graph. Y equals mx plus b, if you recall that from when you took Algebra 1. That initial height, if you plug in 0, at day 0, at time 0, before we started measuring, the grass would be 0 plus 3.25, or 3.25 inches. So the y-intercept of a linear function, this number here, is the starting value of whatever that particular function stands for. And then this is how it's changing per day, per minute, per hour, or whatever the case may be, okay? Then that leads us to standard form. Now, there are two forms I want to talk about, but the one I want to talk about first is standard form. AX plus BY equals C. See how you can see the A and B separated, and then the C, okay? We want, initially they may not be integers, but we want A, B, and C to be integers, and A to be positive, a positive integer. So we could even call that one a whole number, okay? Now, that form is nice. It identifies that it is a linear function. It also helps us, eventually we'll find the intercepts using that function. But okay, so now that we know what standard form is, let's rewrite example 3, rewrite these in standard form and find the A, B, and C, okay? So what we want is we want the x to come first. So we want to bring that to the other side. So that's, we have to subtract it. So it's subtracting 4x, so negative 4x plus 2y equals 5. But one of the things I said earlier is that the a, which is our coefficient on our x, has to be positive. So to finish out this process, we're just going to multiply through by negative 1. That'll switch that to a positive, and then it'll just make it a little easier. So we get positive 4x minus 2y equals negative 5. That's standard form for that particular linear equation. Let's take a look at the next one. This one's nice. You just add 9 to both sides, and you get 3x minus 6y equals 9. Now let's make a little note up here that the greatest common factor of A, B, and C should equal 1. Meaning, if we can divide all those numbers by the same thing, you should do it. So meaning, it's like reducing a fraction. So all of these are divisible by 3. So let's divide this entire thing by 3, okay? So we get x minus 2 equals 3, okay? Now, why is that helpful? So that would be our standard form. Eventually, we're going to talk about how we should, how we can find the slope using that equation, how we can find the intercepts using that equation. So the simpler it is, the better, okay? And then our last one here, let's put the y on the other side by subtraction. What I notice is that this number here is a fraction. Now, I've played with equations with you a little bit and shown you that if you multiply through by a common denominator, well, hey, that's great. Because what you can do is if you multiply that by the common denominator 2, it will become an integer. Okay, so let's multiply this equation, everything times 2. Okay, when we do that, that's going to be 1x. So just write it as x. And then 2 times negative 4 is negative 8. 2 times negative 17 is negative 14. And then just check, did I choose the right denominator? Yes, nothing is funky or weird. We're good to go, okay? Okay, now let's talk about intercepts from an equation and intercepts from a graph, okay? The intercepts from an equation. The x-intercept is where we hit the x-axis. A function may have more than one, but a linear equation just is going to hit it once at most, okay? A y-intercept is where we hit the y-axis. Now let's think also about the algebra that goes with that. If I'm hitting the x-axis, the y value will always be 0. If I'm hitting the y-axis, the x value will always be 0. So remember, we want to try to link what the graph looks like and what the equation looks like. And so, by looking at where it hits the x or y axis, we can see that on a graph. And this is what we're going to do when we get to the algebra part of things. So on this graph, this point right here is hitting our x-axis at the point 2, 0. So 2, 0 is our x-intercept. If I could spell. There, that looks better. And then the point 0, negative 2 is our y-intercept, where we've hit the y-axis. And look at what you see. Our x-intercept, the y value is 0. Our y-intercept, the x value is 0. See that right there? So the algebra and the math should always go together. Okay. So now let's practice looking at them from a linear equation. Okay. In C, I've given you the graph. We'll practice that one, but I really want to focus on an example for A and B. So let's look at A. To find the x and y intercept, you want to make what I call the 0, 0 chart. Because if I plug in x equals 0, I'm going to find the y-intercept. If I plug in y equals 0, I'm going to find the x-intercept. Okay? So we're going to make this chart each time. So for our first equation, 2x plus 3y equals 6. First, let's plug in x equals 0. Now, if x is 0, that would be 2 times 0, which is 0 plus 3y equals 6. Or what happens, what you get really nicely is 3y equals 6. Now, 3y equals 6, if you divide both sides by 3, it happens at 2. So that's that one right there. Now, what if y is equal to 0? If y is equal to 0, this term becomes 0. And so you get 2x equals 6 or x equals 3. And so that goes right. The 3 goes right there. So you see, we found the x and y intercept of the linear equation very nicely. Okay. Now, for this form, one is a little easier than the other. Okay. Now, one method I've seen is where you can take this equation, make it look like, like negative 2x plus y equals negative 5. You could actually do the standard form. That's okay. But we're just going to plug the values in. If I plug in 0, I get y for x. Now I'm plugging in 0 for x. If I plug in 0 for x, I get y equals 2 times 0 minus 5, or negative 5. That's this value right here. That is called your y-intercept, that b, y equals mx plus b. So that's negative 5. So that one shouldn't be too out of the ordinary. That shouldn't have blown your mind or anything. The other one's a little harder. Watch. Because if y equals 0, this value is 0. So we get a very strange looking equation, but we need to solve it. Let's add 5 to both sides and divide by 2. Now, if you want to call it 2.5 so we could find it on the graph, that's fine. If you want to make it 5 over 2, that's also fine. And then how can you check your work? Well, go into Desmos. And in Desmos, all you got to do is type this equation. It better hit the y-axis at the point 0, negative 5, the x-axis at the point 2.50. So Desmos is a way to check your work, okay? It's a really great way to check your work. Okay, and then C, I'm sorry, it's just like the top one there. This is our, we're hitting the x-axis, so that's our x-intercept. Here, we're hitting the y-axis, so that's our y-intercept. Okay, and then eventually we'll practice even, well, if we have a picture but not the equation, how can we find that? So that's kind of the next phase of things, okay? So your homework's on the next page. Please grab, do we need graph paper for this one? Yeah, so example 4 here says to graph using the intercepts. So please make sure you grab a sheet of graph paper off of the side table for yourself. And you're just working on the odds in this assignment. So, 17, 19, 21, 23, 25, and so on. So as soon as you get done with this, make sure you take a picture. Oh, I do want you to do this one even though it's not odd. Okay? And so when you're done with the assignment, take a picture of your notes and your homework, put it into Google Classroom. There you go. Thanks.